Hello class. Today we're going to talk about angles of a triangle. So the last couple days we've been working on this particular standard, and the one that we've been looking at, or the part of this standard we have been looking at, it's been right down here. Angles created when parallel lines are cut by a transversal. Okay, so we've learned various things about that, where this line right here is cut by this is our transversal and these are our lines, and then there are certain relationships that we have based on those parallel lines. Well, in this lesson, I want to focus on the established facts about the angle, sum, and exterior angles of a triangle. So we're going to start back to fifth grade. Back in fifth grade, we started learning about the angles of a triangle and how they all kind of go together. So let's look at the triangle angle theorem. And this says the sum of the measures of the interior angles of a triangle is 180 degrees. So if I take the three angles of a triangle, they will always add up to 180 degrees. This is a skill that you learned in fifth grade. Okay, so let's see if we can practice that fifth grade skill, and then we're going to quickly take it to the eighth grade. Okay, so here's an example problem. It says find the missing angle. Well, we know that the 47, the 58, and this x, if I were to add them together, it's going to equal 180 degrees. Well, believe it or not, what this really is an algebra problem, where we could set this up as an equation, where we've got 47 plus 58 plus x is all going to equal 180 degrees. Okay, so when we're looking at these, I want you thinking about it algebraically. So if we were to put the 47 and the 58 together, well, 40 and 50 make 90, plus 8 gives me 98, plus 7 gives me 105. So I get 105 plus x equals 180, because the first thing you do in an equation is see if you can simplify either side of the equal sign, okay, by putting like things together, like we did with the 47 and the 58. So now I need to get this x by itself. So we're going to subtract 105 from both sides. So minus 105, minus 105. We subtract that, we end up with x is equal to 75 degrees. So the measure of this missing angle is 75 degrees. All right? Now, the reason why we look at this algebraically is because we sometimes end up in the eighth grade with problems that look like this, okay, where we do have some algebra involved. Now, there's two ways of solving this problem. One way is you can find out what this angle is supposed to be based on what's given. So I know that this angle is 31. I know that this angle is 90 because that's what the box means. If we were to add that together, I would end up with 121. Okay, so that tells me that this angle right here has got to be a 59-degree angle. But the question doesn't ask what is the angle. The question asks what is x. Okay, so there's two ways of solving this one. Okay, one way is I can take this 3x minus 1, and I know that that angle has to equal 59. So I can set it equal to 59. Okay, now I have a minus 1 here, so to get rid of that, we do a plus 1, and I do a plus 1 to the other side, and we end up with 3x is equal to 60. We divide both sides by 3, and we end up with x is equal to 20. So we know the value of x is just 20. Well, that's one way to solve it. The other way to solve it is similar to what we did on the previous problem. Okay, I know that all three of these angles are going to add up to 180 degrees. So we write the equation based on that. 3x minus 1 plus 90 plus 31 all equals 180 degrees. So now we put like things together, the 90, the 31, and the minus 1, and that gives us 3x plus 120, which is equal to 180. So now I move the 120 over to the other side by subtracting 120, and we end up with 3x is equal to 60, the same thing that we had in the previous problem. Divide by 3, and you end up with x still equaling 20. Okay. So now, knowing that x is 20, I can now find the measure of this angle right here by just substituting the value of x in. 3 times 20 minus 1. Well, 3 times 20 gives us 60, minus 1 gives us 59. So that's an eighth grade version of that fifth grade problem where you're trying to find the missing angle of a triangle. Now, we also need to talk about the exterior angles of a triangle. So let's talk about that. It says in order to comprehend the next theorem, we must learn two more terms that describe angles. The angle formed by one side of a triangle with the extension of another side is called an exterior angle. That's this one right here. Okay? So if I extend this side right here, this becomes an exterior angle. If I extend this side right here, I end up with an exterior angle. If I extend this side right here, I end up with an exterior angle. Actually, sorry about that. I end up with an exterior angle right here. Okay, now I can also extend this side, and I end up with an exterior. This side, I extend an exterior, and this side right here, I get an exterior. So we've got several different types of exterior angles, but the one that is not an exterior is this one that's right here. Those that come off that point, that's not an exterior angle, but we do see that it's vertical to the interior angle. It would be the same as that one. Okay, now, why do we need to know about this? Well, here's what we need to know about exterior angles. It says the two angles that are not adjacent or next to the exterior angle of the triangle are called remote interiors. That's these two right here. Remote means farthest away from. Okay, so these two are the remote interiors. Okay, why is that important? Because the exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interiors. So that tells me that this angle right here, angle 3, is equal to or the same as taking angle 1 and angle 2 and adding them together. Okay, so let's see about that. So here's a 5th grade problem that's dealing with the exterior angles. Now we can find angle 1 and angle 2 several different ways. Okay, so if I were to want to find angle 1, which is an interior angle, I can add these two together, 30 plus 42 plus whatever this angle is here, we'll just call it x. I know it's going to be equal to 180 degrees. So if I add these two together, I know I'm going to get 72 plus x equals 180. We subtract 72 from both sides, and I end up with x equaling 108. Okay, so I know this angle right here is 108 degrees. Now I can find angle 2 because I know it is the supplement of angle 1. So I know angle 2 based on this is 72 degrees. Well, if you notice this angle right here, it's the same as angle 42 and angle 30 put together. So that proves that particular theorem, right? That this exterior angle is equal to the sum of the two remote interiors. So let's see if we can do another one like that real quick. So here's an example. Okay, I'm looking for x. I want to know the measure of that angle. Well, the measure of this angle is equal to the measure of angle 21 plus the measure of angle 34 put together. So 34 and 21 gives us 55. So x is equal to 55 degrees. Now that is a 5th and 6th grade version of an exterior angle. Let's look at a 8th grade version. So here is an example. Okay, so this one says this exterior angle is 94, and I'm looking for the value of x. I'm not looking for this angle measurement. I'm looking for the value of x. So, well, I know that this 94 is equal to 60 plus 2x. So we can write the equation. 2x plus 60 equals 94. Okay, so to solve for x, I get rid of the 60. So I subtract 60 from both sides. I end up with 2x is equal to 34. So that 34 is actually the measure of this angle. But I'm looking for angle x, or the measure of what x is. Okay, so I have to go ahead and solve this. So I divide by 2, x is equal to 17. So the value of x is 17. So what we looked at today is we looked at two things. Okay, we looked at one, that the interior angles of a triangle are always going to equal 180 degrees. We also learned how to define an exterior angle. That an exterior angle is the angle formed by one side of a triangle with the extension of another side. It's called an exterior angle. And to find that exterior angle, all I have to do is add the two remote interior angles together, and I will get the exterior angle, or the measure of the exterior angle. So that's it for this lesson. Until next time.